Hello student, in this virtual lab we are going to see about the Yarwich experiments. It is also called Newton's ring experiment. So this is because it is generated due to the interference of light. So concept is the distribution of superposition light waves, which is known as interference. And now we can see the picture. You have a glass plate over here and you have a convex lens over here. Traveling microscope is here. If a glass plate is placed between a air film and the traveling microscope, superposition of waves will take place, so that we will get the Newton's ring. Okay, now by using the Newton's ring we can calculate the wavelength of light using this formula. Lambda is equal to dn squared minus dm squared divided by 4 n minus m into r, where dn and dm are the diameters, n and m are the ring number, and r is the radius of the convex lens. So this one is the theory. Okay, so how the Newton's ring formed? That is due to the superposition of waves, so that the Newton's rings will formed. Okay, and here I'm going for the simulation. See here, click for the simulation. So we have to attend the pre-test. The following, which one is convex lens? This one is the convex lens. Consists of concentric rings. Okay, now further. Second answer, third one, submit. I'm going for the simulator. Select any medium. I'm selected water. Now you just select show the apparatus, so that it will show you the telescope, the glass plate and the convex lens. Okay, switch off the light, so that the Newton rings get formed. That is because of the superposition of the light waves. Next, least count of the traveling microscope is 0.001 centimeter. So now I'm just giving submit. So now show the traveling microscope. See here the traveling microscope, and I'm just moving the lens down up, so that we will get more and more concentric rings. See here the rings is formed. The rings is formed because of the superposition of the light waves. Now our aim is to move this focus from one ring to another ring, and we are going to know the vernier scale and main scale, and we are going to add up this in the table. If we add up in the table, this simulator will show you the wavelength of the light. Now see, I'm just moving this focus. This is vertical crosswire, this is horizontal crosswire. I'm going to move this focus to the right, just coincide in this point. Okay, in this first circle you will have a vernier scale, main scale. Now I'm adding this to the table, so this one is added up. Okay, now I'm moving again another ring. Okay, moving to the another ring. Now I coincided. Now the vernier scale is 28, main scale is 10.05. Add to the table. So this reading is added to the table. Okay, so we are moving towards right. Now again I'm moving right. Okay, so now see, vernier scale is 5, main scale is 10.10. Add up to the table. I have added this reading is added. Again I am moving. Vernier scale is 23, main scale is 10.10. Add to the table. Okay, now we are completed in the right side. So now we are going to move it in the left side. Just see, first ring on the left side and coincide at the one end. Now just note the vernier scale 1, main scale 9.95. Add to the table. Again I'm moving to the another second ring. Vernier scale 18, main scale 9.90. Add to the table. Again I am moving to the third scale. vernier scale 46, main scale 9.85, add to the scale, again to the next ring, vernier scale 24, 9.85, add to the table. Now see, left you have certain readings MSR and vernier scale, and right you have MSR and VSR. Now generate graph. So if we generate graph, see the graph. Okay, it is now see here the wavelength is get calculated. The wavelength of the light by using this Newton's ring method is 4430 into 10 power minus 8 centimeter. Okay, so this is how we have to do the experiment. Thank you.